Scientific notation. Well, scientific notation is a number like that, 2.03 times 10 to the fifth, and it represents a very large number. Well, to use scientific notation, we're just going to move the decimal point the number of times that the exponent is. We're going to move it 5 times to the right and add your zeros in any spaces. So 2.03 times 10 to the fifth is 203,000. Well, what if it's negative fifth? Well, let's try this out. It's still 203, but we start there and go to the left. We go over 1, 2, 3, 4, 5. And there are 4 little spaces there because we had to move 5 times. So that represents that number. Well, let's understand this. Powers of 10. Those are some examples of powers of 10. 10 to the third power just means 10 times 10 times 10. So it's the same as 1,000. 3 zeros. And 10 to the second power is just 10 times 10. 100. And 10 to the first is just a 10. Well, what happens with 0? Well, we're moving the decimal point over every time, so let's keep moving that decimal point over and see what happens. It's just 1. So 10 to the 0 power, anything to the 0 power is just going to be 1. I kind of scribbled there. Well, we're moving the decimal point. Let's keep moving it to the left. It's 1/10. A negative is going to make it into a fraction. You move it over, and it's 0.1. And to keep moving that decimal point over, it's going to be 0.01. And then 1,000th, 0.001. We're just moving that decimal point. We keep moving it to the left every time we go negative. So we're making them all left, left, left. Go to left 1. And go to left again, and go to the left again. So let's actually use these powers of 10 now to write a number that's already in scientific notation. Let me see, we have 5.432 times 10 to the 6th. We're going to take that decimal point and move it 6 times to the right, and just fill in those zeros. That's going to be the number 5,432,000. Let's try it with a negative exponent. We're now going to move it to the left. Well, you write down the number 87654, start where the decimal point is, and then go to the left 4 times. 1, 2, 3, 4. Put your decimal point, fill in those 3 zeros, just little placeholders. So what if you're asked to write a number in scientific notation, like 16,000? Well, you write one number, then a decimal point, and then the rest, 1.6. and multiply it times the power of 10. Here it's going to be 10 to the 1, 2, 3, 4th power. Let's try another one. Let's try a decimal. Let's see, 0.0009. How many times are we going to have to move that decimal point? Well, first off, write one number, 9, times 10 to the 1, 2, 3, 4 times. So it's going to be a negative 4. Now let's look at some real-world examples. Let's talk about something really big, the sun. The sun is very, very large. That's how big it is. That's how many kilograms it has. It's 1,989 octillion kilograms. Well, to write that, we're going to write 1.989. And how many times do we have to move that decimal point? All the way across, that's going to be 30 times. Well, instead of having to write all those zeros, the scientists can just write 1.989 times 10 to the 30th. What about the mass of a proton? Mass of a proton is going to be really, really small. A proton is just a small little part of an atom. That's actually kind of an outdated model of an atom, but you can see that that's proton right there. And that's just how small it is. Well, scientists don't want to write all those zeros. They're a little lazy. They just want to write just the numbers that matter. So you write the 16726,219 and count how many times to the left did they have to move that decimal point to get there. All the way across there, they had to move it 27 times to the left. So it'd be a negative 27. So there's some real-world examples of scientific notation.